Now let's have a look at the properties. Now the property 1, I would like to discuss about property 1, and that is nothing but expectation of C is equal to C. Now you would be wondering what C is. C is nothing but a constant. Okay, constant in the sense it can be any number. Okay, it's not a variable. So keep that in mind. C is a constant, not a variable in this case. Okay, now X is a random variable. Okay, X can be continuous or discrete. We have studied that before. We know two definitions of mathematical expectation when X will be discrete and continuous. Keep that in mind. Okay, now f of X is the density function. That is when X is continuous. F of X is the density function when X is continuous, and P of X is the probabilities that the corresponding probabilities of the values that the random variable X takes. Okay, so this comes when in the case of when X is discrete. Okay, now here we have two cases. Again, first case is when X is discrete. When X is discrete, we have to prove what expectation of C is equal to C. Now let's just expand this left hand side. Expectation of C, let's take expectation of C is equal to, you all know the mathematical expectations formula when X is discrete. So just I'm going to ask you a question. What is the mathematical expectation of X when X is discrete? Yes, you have answered it correctly, and keeping that in mind, we can expand this. How? Summation C multiplied by P of X. Okay, now since C is a constant, you can take it outside. Then this is what you get when you take C outside. So what is this summation P of X? Now tell me, what is summation P of X? Yes, you said it right. Summation of all the probabilities is equal to 1. That we have studied again when we studied about the definitions of mathematical expectation. So here I am going to write summation P of X is equal to 1. Now substituting this over here, you get C into 1, which is equal to C, hence proved. In the case when X is discrete, you have one more case when X is continuous. So just note down all these things in your notebook and keep it for yourself. Okay, now let's have a look what happens when X is continuous. Now, okay, so I have written here it's a continuous case. So expectation of C is equal to, since X is a continuous case, I have put this integral mark, C multiplied by f of X dx, which is equal to, since C is a constant, obviously you will, yes, take it outside. So it's nothing but C integral minus infinity to infinity f of X dx. So what about this term? What is integral minus infinity to infinity f of X dx? Yes, you have answered it right. Now that is a property of what? Of the density function, which you have already studied in your last semester. So this is equal to 1. Now, which implies C multiplied by this value 1, which is equal to C. Hence proved E of C is equal to C. So that means the expectation of a constant is a constant itself. Okay. So take down the continuous case too. Next we are going to study about the expectation of function of a random variable. Now let's have a look at what does this bit sentence means. Okay, now till now you studied expectation of a random variable. That means you have studied what? You have studied about E of x. Now you are going to study about expectation of function. Okay, so this comes in function. So before that I have to introduce some terms. You are already familiar with x, right? X is the random variable. Okay, then f of x is the what? Density function. Then comes another function called phi of x. Now phi of x is a function of x. Phi of x is a function of x. So this is the new person. Okay, now just connect this sentence with all these things. Okay, what is written over here? Expectation of function of a random variable. So that means expectation of a function means, or expectation of something means what? E of something. In this something, what they have emphasized is on function. Function of a random variable. Function of a random variable. That means phi of x. So expectation of phi of x is equal to what? That is what we have to find out in property 2. Now here also you will have two cases, x being discrete and x continuous. Now let's have a look when x is discrete. Okay, so the first case is when x is discrete. What is expectation of phi of x? Now you have to keep the definition or the formula that you have studied for expectation of x in your mind while writing this. So what is expectation of x when x is a discrete random variable? Yes, you said it. That is correct. So apply that over here. You will get summation phi of x, p of x. So this is the answer. That's all. It's as simple as that. Now when x, so this was the case when x is discrete. Now we have to look when x is continuous. Now have a look at the case when x is continuous. Again, we will write expectation of phi of x is equal to, so when x is continuous, what was expectation of x? Yes, correct answer. So just apply that over here. What you will get, since x is continuous, you get integral phi of x, f of x. So that's it. So that is your property number 2. Now the next property is nothing but expectation of c into g of x is equal to c into expectation of g of x. So we have to prove this. So for that we can take the LHS first. Now here you have to be clear that there are again two cases, when x is continuous and when x is discrete. Okay, now here I am going to prove this equation when x is continuous. The discrete part I'm going to give you as an assignment. Okay. Now let's take the LHS first. Now what is the LHS over here? Yes, you said it right. Now expectation of C into G of x. Okay. Now you know what the definition is for mathematical expectation when x is continuous. So for more clarity, I will write here x, the case when x is continuous. Okay, so this is the case when x is continuous. So you can write this as when x is continuous, integral minus infinity to infinity C G of x f of x dx. Right. Now, what about C? C is a constant, so you can take C outside. Integral minus infinity to infinity G of x f of x dx. Now, what is this term? What is this part? Just recap yourself. The property number. Yes. So, what is it? What is the answer for this? Yes, that's the correct answer. So, C into, what is this? This property is nothing but the expectation of a function of a random variable x when x is continuous. So we can write that as what? Expectation of G of x. Now have a look. Can you see that we have proved this equation? Okay, so that's it. So that is the property. Now regarding the discrete case, that is a small assignment for you, and complete it as soon as possible. Okay, now that you all are experts, we will prove the property number 4. Okay, now what is property number 4? Here, expectation of Ax plus B is equal to A into expectation of x plus B. Now let's take the left hand side and check whether we would get this RHS. Okay, so expectation of Ax plus B is equal to, now here I am taking a general case. X can be continuous or discrete. We are not moving into details of that because you already are experts, right? Now we won't be expanding any of these. Let's check what we can do to get the RHS. Okay, now expectation of Ax plus B. Now let's split this. Expectation of Ax plus expectation of B. Okay, here using a property you can write the answer of expectation of Ax. Now what is the answer of expectation of Ax? Yes, correct. Now A into expectation of x, right, plus again here expectation of B. So before that, I'm really sorry, I would like to introduce all these terms. A and B are constants, so keep that in mind. X is a random variable. Now what is expectation of B? Yes, that is correct. Expectation of B is B itself. So hence we proved the property number 4.